So, yeah, thanks, Pradeep. So, good morning again. I see over 30 people on the live stream now. So, thanks for joining. It's great to see this kind of engagement on the very first webinar here. So, today, when Pradeep and Craig and Madhu asked me to cover some topic of interest, I thought what would be most suitable would be to cover the programming concepts in Earth Engine that are very different than traditional programming. So one thing that I personally faced and I hear from beginners in Earth Engine is that when you start programming in Earth Engine, the programming model is quite different than what you're used to. So many of you would come from coding in Python or R, or you may have used a desktop software where you have certain workflows. And when you start implementing those workflows in Earth Engine, you quickly run into some uh, constraints where you can't really translate them effectively from what you are used to how Earth Engine works. And for example, there are basic programming constructs like for loops or if and else statement that you find that they are missing in Earth Engine. So rest assured, they are not an oversight in Earth Engine. They are very intentional design choices, and there are equivalent options available to you to kind of use those kind of constructs in a different way. So I wanted to kind of cover that. It is useful material for beginners as well as intermediate users who are kind of used to Earth Engine, but don't really have a good grasp on why these things are. So I'll spend 10 minutes on covering those. Let me share my screen first. So this is the code editor that you are familiar with. This is how you start using Google Earth Engine. And before we dig into the nitty gritties, I wanted to show you our user guide. Many of you would have seen it, but it's got a lot of rich resource material and it's being updated constantly. There are some new stuff that has been added recently. So I just want to quickly show you how you can get help when you are working with Earth Engine. So on the top right corner, there's a help button. And the first link there is the user guide here. So the user guide is divided into 5 different sections. The first one are the guides. So these are the step-by-step guides. This got some theory. Many of them have a video and have some code samples along with it to help you understand how to carry out certain operations in Earth Engine. So for example, if you are interested in computing textures of images, then you can look at this section of the guide. It has got some theory of what are textures, how you use them, and some code samples that you can quickly copy paste and get started. So very useful. There are a whole bunch of guides available from everything from data import exports to uh, classification, etc. There is also a tutorial section here, which covers basic tutorials of the Earth Engine API, JavaScript, some of the more popular data sets, as well as some video tutorials. So if you like to watch videos and learn, this is great material for all of you. I want to quickly highlight there's a new section here called Data Catalog. This is, if you work with Earth Engine, you know that when you search for a data set, you get some data description about the data. So these data catalog are the new pages where there is a whole lot more information available about the data sets, and all of our petabytes of different data sets are cataloged very nicely with useful material. So I encourage you to check this out, and this is a recent addition. The material that we're going to cover today is under the tutorials tab here. If you click on the introduction to JavaScript for Earth Engine, there is a page that is functional programming concepts, and this is also new. So if you've done tutorials earlier, you would not have seen this. So let me switch back to the code editor. Now the topic of this page is called functional programming, and why functional programming is because traditionally the other programming that you would have done in R or Python is called procedural programming. And functional programming differs in kind of very unique ways. In Earth Engine, if you wanted to process some data, uh, Earth Engine is a parallel computing system. It needs to break down your computation into multiple chunks, and each chunk gets sent to a different machine for computation, and all the results get combined and sent to you. And that's why Earth Engine is very fast at certain operations which are very slow in other systems, because other system would need to process the data in sequence. So if you want to process 10 images, each image will get processed, the next image will get processed afterwards. In Earth Engine, all of the 10 will get processed in parallel. And this is very useful in context of big data and remote sensing, but it also poses certain constraints on the programming, because you need to make sure that each computation that is happening is independent of the other computation. So when you're processing one image, you would not have information about the other images, because they are being processed in a different machine separately. So you need to break down your computation into independent functions, and that's why functional programming is a paradigm that is very applicable to this kind of system. So let me demonstrate it, how that differs in implementation. So the first thing we're going to cover is for loops. When you start reading about Earth Engine and see the tutorials, you will see that the use of for loops is highly discouraged in Earth Engine, and most of the API would not even support for loops. So how do you solve a problem like this? Given a problem of, say, a list of numbers from 1 to 9, the problem is compute a list of squares of each number. This is a very simple problem. In Python, you would do something like this, where you would initialize a list and then go through each element of the list, compute the square, and append to the list. Now, this kind of, if you code like this in Earth Engine, it won't work, because this is a sequential programming, and Earth Engine doesn't support it. To do it in Earth Engine, you need to apply a functional programming paradigm. And functional programming is essentially defining a function which can work on one element of the list independently of each other. So Earth Engine implementation would look something like this, where you would define a function, say, called compute squares, which takes one number and returns the square of that number. Now, once you have this function, all you need to do is use the operation called map. So take the list, map this function over it, and you get a new list, which are the squares. Now, how does this work? Since the function knows how to compute the square of one number, each of these 10 numbers can be processed independently by the same function, and they can be processed in parallel. And then once all the results are ready, they can be combined together. So theoretically, if you had enough machines available, the time it takes to compute square of 10 numbers would be equivalent of computing square of 10 billion numbers, since all of them can be done parallel. So you can see how this kind of model is very advantageous. So for loops aren't missing from Earth Engine. They are just, you need to code them differently using map and a function. Another kind of constraint you would have is if and else statement. So if I define my problem a little differently, where given a list, I want to compute the squares of only odd numbers. Now, in a traditional programming, you would just say, go through each element, check whether this element is a square or not, and return the square only if the number is an odd number. Now, how can you do this without if and else condition? So in Earth Engine, in functional programming, you need to get a little smart about it. How do you define a function? So here there's one implementation where I've defined a function which says get odd numbers, where when you pass a number, it multiplies the number by its remainder. And if the remainder is 0, you'll get 0. If it's 1, you'll get the number back. So this is kind of a smart way of saying that, I'm defining a function where I get 0 if it's an even number, odd when it's, and the number back when it's an odd number. And once I map this function to my list, I can just remove all the zeros and then compute my squares. And this might seem like a roundabout way of doing things, but in practice, this is very fast when dealing with large data. And once you start getting used to thinking like this, you can become a very you can code very efficiently in Earth Engine. You may not encounter such problems before in Earth Engine often. The problems you'll encounter are more in nature of working with image collections or feature collections. So say given a collection, you have a collection of images and you want to apply different algorithms saying if the sun angle is greater than 40, do this. If the sun angle is less than 40, do that. So again, you can have an if-else condition in procedural programming like this. In Earth Engine, the way you do this is using filters. So you can divide your collection into two parts using filters, one that is less than 40 sun angle, one that is greater than 40, and then apply different algorithm to both of them. So you are processing both of them differently, and then once the processing is done, you can merge them. So same way of getting a different way of getting the same result, but this is much more fast and efficient. The last topic is cumulative iteration. There are certain class of problems where you can't really implement in a pure functional way. You need to have some idea of what was done before or what is being done to the other elements of the list. So in that case, Earth Engine provides a function called iterate. Now, I must warn you, this is useful, but before using it, see if you are able to use filters or map to achieve the same results. Because the iterate function is sequential and it would take a lot longer to process. So your code will slow down. But this is useful in certain cases. So this is an example of a Fibonacci sequence. If you want to generate that, a Fibonacci sequence is essentially each number is a sum of the previous two numbers. So there is no way you can generate this without knowing which are the past two numbers. So in this case, you can use iterate in Earth Engine, where the iterate function takes an algorithm and an initial value. So you initialize with a certain value, and the algorithm itself has access to the current and previous elements. So then you can compute for each step, it knows what was the result of the previous iteration, and you can generate this. I give you a practical example where I had to use it recently, where I had a bunch of cloud masks, which I wanted to apply to an image in iteration. So I wanted to apply the first mask, then the resulting image needs to be applied the second mask, and so on. And an iterate is kind of an ideal function to use where you can apply one mask, get the result, apply the second mask, etc. So in the image processing world, this is where you might end up using iterate function. So to summarize here, key takeaways: use map instead of for loops, use filter instead of if-else, and use iterate when you need to use access to the previous value. So hope this was useful. And if you have questions about this, you can write them in the live chat. I'll be monitoring that, and I can address those at the end of the webinar today. Now I'm handing over to Pradeep, who's going to cover data import.